Hello, we're going to have a look today at how we'd go about doing our task for week 2. Basically, the key idea of this week is that atoms will bond together if in bonding together they are able to become on the outside the same as the noble gases. So the noble gases are the very special elements that have a very stable set of electrons around the nucleus, and every atom basically wants to be a noble gas. And if it can be a noble gas by grabbing electrons or giving away some of its electrons and on the outside look like a noble gas, then it is going to do that. So we'll start off by just going up here and having a go at drawing the sodium atom. Now, previously you were drawing atoms by putting individual dots for protons and neutrons. We're not going to worry about that today. We'll just label them with numbers, which will make your life easier. So it's fairly easy to have a look at it on the periodic table. Sodium's got an atomic number of 11 and an atomic mass of 23. So it must have 11 protons and 12 neutrons in the nucleus. So we'll go and pop that in. So let me go and find my... So we're going to write that in. So it's got 11 protons. Protons. And it's got 12 neutrons. And then on the outside, it's got to have 11 electrons. Excuse me. Not working. Then we do fluorine. Fluorine's the 9th atom on the periodic table, so that means that in its nucleus it's got 9 protons. It's got an atomic mass of 19, so therefore must have 10 neutrons. And on the outside, it's got 9 protons, got to have 9 electrons. So again, I'm not going to draw individual dots here. You'll get the idea just by me drawing this. So what happens when sodium and fluorine approach each other? Well, it turns out that for both of these elements, the nearest noble gas element is neon. Neon's got 10 protons and therefore 10 electrons. Now sodium's got 11 and fluorine's got 9. So they can solve the problem and get 10 each, which is what they're aiming for, because they want to be like their closest noble gas, which just so happens to be neon. They can basically go and get it by sodium giving an electron to fluorine, and then they've both got 10, which is what they were aiming for. So if we draw it this way, now the sodium, I won't bother to put the neutrons. I will just so you can see. The sodium atom now has got 11 protons, I'll just write P for protons, 12 neutrons. But on the outside, it's going to lose one, so it's only going to have 10. Alright, E for electrons. And the fluorine is going to get one. So it's going to have its 9P and its 10N inside, and it's going to get its 9 electrons. Sorry, my apologies. Let me see if I can rub this out. It's going to get now 10 electrons. So it's going to go up by 1, just like the sodium went down by 1. Now, if we have a look at these two atoms now, the sodium atom has got fewer electrons and protons, so it's now going to have a positive charge. And the fluorine atom has now got more electrons and protons, so it's going to have a negative charge. So even though they are now happy that they've got their 10, and 10 was what they were aiming for because they wanted to be like a noble gas, and for both of these it just so happens the noble gas is neon. It's got 10, it's the closest one on the periodic table, so they're both happy. Sodium is positive now and fluorine is negative, which means they will hang around together, so they will be attracted to each other and will basically be stuck together to form a compound called sodium fluoride. So that's the basis of chemistry. It's the trading of electrons so that each atom can be like a noble gas on the outside. So if we went down here, we'd basically be saying, whoops, let me just go and reverse this. What's the difference between this? Is that the sodium has an extra electron. Sorry, the sodium has lost an electron. Na has donated an electron to fluorine. Fluorine, another way, fluorine has grabbed an electron. So they're both happy. That's meant to be an A. There we go. Okay, let's go a little bit further down. Now, we sometimes get compounds that have got more than one atom of each thing. So for the first one, NaF is just the one we've done. As you know, there's one sodium and one fluorine atom. When we go to the next one, there's one magnesium, but the little 2 underneath refers to the element just before the 2, and the element just before the 2 is a fluorine, 2 fluorine atoms. And the final one, H2O, is the other way around. The 2 belongs to the H because it's just after the H, so it's 2 hydrogens and 1 oxygen, and that's our very famous compound, water. Okay, let's move on. Let's go to the next page. And this is basically the same thing all over again. That if we draw the Mg atom, we're going to end up. Let me just go and erase this extra line I put on. Not working for me. Never mind. We'll pretend that the line isn't there. All right. So let's draw the Mg atom. The Mg atom is basically going to have its atom number 12, and it's got a weight of 24. So it's basically 12 protons, 12 neutrons, 12 electrons. And the O atom, if I go further down, the O atom is the 8th atom on the periodic table with a mass of 16, so it's 8, 8 and 8. 8p, 8 neutrons, 8 electrons. Again, their closest noble gas is neon, which has got 10. So how do they solve the problem? Magnesium loses 2, oxygen gains 2. So they both go to 10. So, whoops, let me just go up. So now, if we do it in this one, we're going to end up with Mg now is going to be still 12p, 12n in the nucleus. Nucleus doesn't change, but now it's going to have 10. It's going to, because it's lost a couple, and the other one, the oxygen, is going to be 8p, 8n, still the same in the nucleus. But on the outside, it's also going to get 10 because it's gained 2. So basically, magnesium is given 2 to oxygen, so they've both got 10 each. they're both like neon, they're both happy, which means now this atom is going to have what we call it's going to have a 2+ charge because it's got 2 few electrons compared with the number of protons, and this has got too many electrons now, so it's going to have a 2- charge. And you'll notice how always, because the electrons were traded from one to the other, overall the charge has to balance. In a similar way, we can then go down and work this same process out for every element, but it's quite useful to know where our nearest noble gas is. Now, for the moment, it's always been neon, but it's not always going to be neon. So, for example, helium has got 2 electrons, so it's one that elements that are close to 2 might want to be. Like, for example, lithium might just want to lose 1 to become like helium. Neon has 10, the one we've been doing, and if we go to the next page, argon has got 18. I quickly need to go and check something on the periodic table. I'm fairly sure krypton's got 36, but you can basically go and look eat up on the periodic table. Let's move down to the next question. And then now we can work out what happens. So, for example, lithium is fairly close to helium. Therefore, it's going to donate 1 electron, so it can go back to the 2. Beryllium's also fairly close to helium. It's got 4, so it's going to go, pop the 4 in there. So it's close to helium, but this time it's going to donate 2 electrons. And boron's 5, which again is closer to the 2 of helium than the 10 of neon. So in this case, it's still close to helium, and it's going to donate 3. So it can go back to the 2 that it wants to get to. Go further up, and we get to fluorine, and in this particular case, fluorine's 9, and 9 is fairly close to the 10 of neon. But in this case, it's got to go up 1, so it's got to grab 1, so it grabs an electron. Sodium's the other side of neon. It's got 11, whereas neon has 10, so it's going to go the other way, and it's going to give 1. And we can keep on going all of the way down. So I'll just do one compound for you, which is the lithium fluoride. So if I'm where I'm doing lithium fluoride, lithium's the 3rd element. It's got 3 protons, 4 neutrons, because its weight 7. 4 neutrons. And it's got 3 electrons. And on the other side, we've got fluorine, which, just like before, was 9p and 10 neutrons. And it's got 9 electrons. So when we form a compound, all we do is we move them to their closest noble gases. The closest noble gas to lithium is helium, and helium's got 2, so lithium will lose 1, come 2 electrons, and the closest noble gas to fluorine is neon, so fluorine will gain 1 and get to 10, and now they're both happy, which means overall this is going to have a charge of 1 positive, and this is going to have a charge of 1 negative now, which means they're going to stick together and hang around like a couple. Okay, I'm just going to do you one more, and then I'm going to leave you on your own. The one I'm going to pick to do, because it is a tricky one, the one I'm going to pick to do is this one over here, potassium oxide. Alright. So let's pop up potassium. Potassium has got it's got a weight of 40, and it's got 19 protons. Sorry, a weight of 39, and it's got 19 protons and 21 neutrons. So we'll pop in the 19p there, and the 21 neutrons. That means it's got 19 electrons. Oxygen. So this is potassium. Might just write potassium so we can remember that's potassium. Then oxygen over here has got 8 and 8, and 8 electrons out here. So that's our oxygen. Let's label it as oxygen. So now we've got a problem. Our problem is that oxygen wants to become like neon and get 10 more, but the potassium can only give it 1. So how do we solve the problem? We have another potassium atom. So we have another potassium atom, because there's lots of them floating around when they are reacting chemically. So we have 19 so we'll take another potassium atom, and this has now got 19 electrons too. And then now what happens is oxygen wants to gain its 2 to become like neon, so it goes to 10, and that means that each of the potassiums wants to lose 1 and become like argon, which has got 18, which is another noble gas, so they lose 1 each. And that's why the formula is K2O, because each potassium atom can only give the oxygen atom 1. Therefore you need 2 potassium atoms so oxygen can gain its extra 2 and become like neon. Okay, I will leave you to continue on with these questions. Hopefully this video has helped you get the idea.